you have spent years in mainframe or you are just breaking into it. And now there's an IMS interview standing between you and the job. IMS interviews. Here's the hard truth. Most of the candidates fail not because they cannot code, but because they cannot articulate what IMS is really doing under the hood. In the next 15 to 20 minutes, I'm going to walk you through the most critical IMSDB and DC interview questions with precise, confident answers that will impress any hiring panel. Whether it is your first mainframe role or your fifth, the Q&A framework in this video will give you an edge in your interview. And do watch this video till the end because I've also included a special rapid fire scenario section that outline couple of important key terms and definitions, and you often get questions about those terms in your interviews. So don't skip it. So here's a brief summary of what we will be covering today. So very first thing is fundamentals. What IMS is, its two major components, and the control block architecture that everything else depend on. Second important thing is the DLI call interface, all the data manipulation calls, how they sequence, and the gotchas interviewers generally test. Third important thing is IMS DC, that is transaction processing, regions, MFS, and scenario-based questions. So let's begin with our first section, that is IMS fundamental questions. So very first question is, what is IMS, and describe its two main components. So IMS stands for Information Management System. It is an IBM hierarchical database management system that runs on z/OS mainframe. It has two main components. The very first one is IMSDB, the database manager. IMSDB is responsible for the physical storage, structure definition, and retrieval of data. It actually manages how the data is physically written and read from the disk. And it also enforces the hierarchical parent-child relationship that defines every IMS database. The second key component is IMS DC, and it is also known as IMSDM, that is Transaction Manager or a data communication component. IMS DC handle online transaction processing, so when a terminal user submit a transaction, IMS DC route it, queued it, schedule it into an appropriate region, and then manage the response back to the originating terminal. Now, when an interviewer asks this question, they are actually checking whether you understand the separation of concerns. That is, IMSDB is about persistence and retrieval, IMSDC is about transaction routing and online execution. They can operate independently, right? You can have IMSDB without IMSDC in a pure batch environment, but in production environment systems, they work together. Now, the next question is, what are the three DLI control blocks? Describe each one. And this question comes up in virtually every IMS interview at entry level. Now, there are three control blocks, that is DBD, the PSB, and the ACB. The DBD is database description. It actually defines the physical structure of the database. It specifies the segment type, the field name, the key fields, and the hierarchical relationship between the parent and the child segment. And of course, the access method being used, for example, HDAM or HIDAM. So in a nutshell, the database description or DBD is basically the blueprint of the database. Now let's talk about the next one, that is PSB or Program Specification Block. It actually defines the logical view that a specific application program has of one or more database. The PSB contains one or more PSBs. It specifies which database the program can access, which segment it can see, and what operations it can perform on the database. For example, read-only, insert, replace, delete, and so on. And remember, one program has exactly one PSB, that is Program Specification Block. Now the next one is the PCB, that is Program Communication Block. It actually sits inside the PSB and defines the specific access path for a single database within that program. The PCB is what the program actually references in its DLI call. After every DLI call, IMS return a 2-character status code into the PCB. The program read the status code and determine whether the call was successful or there was an error or the record was found or not found. Now the last control block is ACB, that is Application Control Block, and it is basically a combined pre-generated structure that merge DBD and PSB together. The ACB is built at system generation time and stored in ACB library. And remember, every setup has their own specific predefined libraries, right? So at runtime, IMS load the ACB rather than reading the DBD or PSB separately, which actually improve the performance. Now, the key takeaway is that you should clearly understand the distinction between all these control blocks. So DBD is about the database, PSB is about the program view, PCB is about the runtime interface, and ACB is about the performance optimization combined. Okay? Now the next question is, what are the IMS database access method? Explain the key differences. Now, as you all know that IMS support 4 full functional access methods. Apart from that, it also support the fast path option, that is DEDB and MSDB. I will going to talk about all these one by one. So very first one is hierarchical sequential access method, that is HSAM. It is basically the simplest and the most restricted. Segments are actually stored physically in hierarchical sequence. There is no index and no direct access. You must scan from the beginning, and these databases are essentially read-only after initial data load. So you rarely see these databases in modern production systems, but generally interviewer asks these questions to test your foundational knowledge. Now the next one is hierarchical index sequential access method, that is HISAM. So this is basically an improved version of hierarchical sequential access method, and it is done by adding an index on the root segment. So this would eventually allow index access to root segment and sequential traversal of dependents. It is suitable for workload with low insert activities and sorted data access patterns, such as processing all customer records in alphabetical order. Now the next category is hierarchical data access method, that is HDAM. It actually uses a randomizing module, sometimes called as hashing algorithm, to compute the physical storage address of the root segment from its key value. This actually gives extremely fast random access to the data, and it is also preferred choice for high volume online transaction processing where you need to retrieve a specific record immediately or as fast as possible. The trade-off is that the sequential processing is not ordered and the records are scattered by the hash. Now the next one is hierarchical index direct access method, or HIDAM. It actually combines the best of both worlds. It uses a separate index database to locate root segment, giving ordered sequential access while maintaining pointer-based access to dependent segments. HIDAM requires 2 DBDs, one for the data area and one for the index. It is the most efficient choice when an application needs both random access and ordered sequential processing. In modern IMS, you will also encounter PHDAM and PHIDAM. So these are basically partition variants that support high availability large database architecture. And these databases can span multiple partitions and can be reorganized online without taking the entire database offline. So knowing the key differences and application of these databases give you an edge in your IMS interview. Now let's talk about our next section, that is DLI calls. Now let's look at a couple of questions on that. So the very first question is, what are the DLI function calls and describe each one of them. Now this is the most heavily tested area in any IMS technical interview, and I'm sure you're going to get questions on these DLI function calls. Now there are 8 core DLI function calls, and let's talk about one by one. So very first one is GU, that is get unique, and it actually retrieves a specific segment occurrence based on a key value provided through a segment search argument or SSA. GU is equivalent to a direct lookup. That means give me the customer record where the account number equals to this value. GU actually establish the position in the database. Now the next one is GN or get next. It actually retrieve the next segment occurrence in hierarchical sequence. It could be top down or left to right. After GU or a prior GN, each subsequent GN call advance position through the database. And this is how you process a set of records sequentially. Now the next one is GNP, that is get next with parent. It actually retrieve the next child segment occurrence under the current parent. And this is critical for processing all dependents of parent without accidentally crossing into other parent's child. And think of it as a scoped GN bounded by the parent. Now the next one is GHU, that is get hold unique. And it is functionally identical to get unique or GU, but it plays a hold or a lock on a retrieved segment. Now you must use this particular function call before any update or delete, and you should keep in your mind that this command is actually a precursor to replace or delete when you know the specific key. Okay? Now the next one is GHN, that is get hold next. It is like GN, that is get next, but with a hold placed on the retrieve segment. And it is used when a sequentially scanning and you want to update a record as you go. Now the next one is GHNP, that is get hold next within the parent. So this is actually a hold variant of GNP, that is get next within the parent, right? And it is used to sequentially process and update child segment under a specific parent. Now the next one is ISRT, that is insert. It's basically a short form of insert. It actually adds a new segment occurrence to the database. Now you must also remember that you should always provide SSA, that is segment search argument, so that IMS know where is the hierarchy to place the new segment. And remember, insert is also used in IMS DC to insert an output message into the message queue. Now the next one is REPL, that is replace, and it is actually used to update the content of a segment occurrence that has already been retrieved with a get hold call. Now, you should always remember that you cannot change the length of the segment. You cannot change the key field value using the replace function call. You cannot use a qualified SSA, that is segment search argument, with a replace call. And if you specify any of these, then your call will fail. Apart from that, you should always remember that the hold from get hold unique or get hold next or get hold next within the parent must proceed with every replace function call. Now the next one is DELT, that is delete, and it actually removes a segment occurrence and all its dependent child segment from the database. And you should always remember that a successful get hold function call must precede the delete function call. And you cannot use a qualified segment search argument or SSA with a delete call either. Now there are two more important what you call function call. First one is for checkpoint and the second one is for restart. Now for checkpoint we have CHKP, and for extended restart we have XRST. And they are actually used to establish synchronization point in long running batch programs, enabling restart from the last checkpoint in case if there is any issue or failure. Now the next question is, what is a segment search argument or SSA, and what is the difference between a qualified and unqualified SSA? So an SSA is a data structure that is passed on a DLI call to tell IMS which segment you are looking for in the database hierarchy. Now there are of two types. First one is unqualified SSA and the second one is qualified SSA. Now, an unqualified SSA contains only the segment name, that is 8 characters padded with spaces if required. Now it actually tells IMS navigate to this segment type, but I'm not specifying a key value. And it is often used with GN calls when you want the next occurrence of a given segment type regardless of its key. Now the next one is a qualified SSA and it actually contains the segment name plus a condition, a field name, a relational operator, and a comparison value, all enclosed in a parentheses. For example, customer with customer number equals to 000012345. This actually tells IMS exactly which occurrence you want. And you should always remember that GU calls almost always use a qualified SSA. Now, interviewers often ask a follow-up question, that is, can you use multiple SSAs on a single call? And the answer is yes, you can specify one SSA per level in the hierarchy you are traversing. So if you want a child segment under a specific parent, you can provide an SSA for the parent level and an SSA for the child level. Now the next question is, what status code must every IMS programmer know? Now again, this is a key question and it is quite important because if you aspire to be a programmer or if you have prior experience with any other programming language and when you are interacting with a database, so whenever you execute any operation on the database, you expect a response and based on that response, you decide whether you need to move forward in the logic or you need to just take a corrective action. So essentially, status code is very important. Now in this case also, whenever you issue a DLI call from your COBOL program or any other programming language, and once that call is completed, IMS will place a 2-character status code in the PCB status code field. And based on the value of this particular field, you can decide whether you want to continue with the logic or you need to take some corrective action. Now, the important thing that you need to note out here is that a blank status code that means 2 spaces actually mean that the call that you have issued is successful and there is no error. And in case if you have any other specific status code other than spaces, that means there is some problem and you have to address that. Now let's talk about the important status code one by one. So very first one is GE, that is segment not found. And this is the most common non-blank code. So on a GU, it means no segment match to your SSA criteria. And on a GN call, it means you reach the end of the database or end of the parent's children. So in your program, you should carefully design your get next loop. And in case if you're getting GE as your status code, then you should stop the processing. Now let's talk about our next status code, that is GB or end of database. It actually returned on GN call and when there are no more segment of any type remaining in the database. Now the next one is insert failed. And you generally get this particular status code when you are trying to insert a duplicate root segment in a database that does not allow duplicates. Now the next one is DJ, that is delete failed, and you generally get this particular status code when the segment specified for deletion was not found or the program did not issue a get hold call first. Now the next one is AM, that is access method error, and it actually indicate a more serious input output or structural problem. Now the next one is AI, that is insert path error, and this is the error message that you generally get when the path to the insertion point was not found. Sometimes you get a follow-up question about BA and BB status code related to PCB sensitivity or PSB access violations. Now let's move on to our next section, that is IMS DC and transaction processing. So very first question is, what is IMS DC? And you need to explain its key processing regions. So IMS DC, also known as IMSDM, is an online transaction processing component of IMS. When a user at a terminal or a connected application submit a transaction code, then IMS Transaction Manager route the input message to a message queue, schedule the appropriate application program, and run it in a processing region. and then send the message back to the originator. Apart from that, there are three primary region types that you must know. So the first one is control region, and it is basically the core of IMSDM. It logs all terminal and database activities, manage message queues, schedule work into MPP and BMP regions, and coordinate system startup, shutdown, and recovery. So everything goes through the control region. Now the next one is MPP, that is message processing region. It is where online transaction programs execute. So when a transaction arrives, IMSDM start or assign an MPP region, load the application program, and execute it. The program issue a GU call to get the input-output PCB to retrieve the input message from the queue. After that, it processes the data and issue an insert call to send the response back to the originator. Apart from that, MPP regions are high priority, short-lived executions. And of course, response time is everything for these regions. Now the next one is BMP, that is Batch Message Processing Region. And these are the regions that actually handle background or asynchronous processing. BMP programs can access IMS database that are allocated to online systems, but they don't require a terminal response. Think of them as a hybrid program that bridge the gap between pure batch and online processing, as they can read and write IMS database while the online system is still active. And they do not interfere with the MPP transactions. Last but not the least, there are also DLI SAS, that is DLI Separate Address Space, and the DBRC, that is Database Recovery Control Region. And these regions actually manage logging, recovery token, and the database authorization. Now the next question is, what is message format service and why it is important? Now, message format service is the IMS facility that control the formatting of messages between application program and the display terminal, specifically classic 3270 terminals. Although they are not used very often these days, but yes, this is what the feature IMS already has. So message format service use 4 control blocks. So first one is device input format that actually describe how the physical input from the terminal is structured. The next one is message input descriptor. It actually map the physical input to the format that the application program receives. On the output side, the message output descriptor actually defines the format of the message that application program sends. Then you have device output format that actually map that logical output to the physical screen layout presented to the terminal user. And this separation of format from application logic is powerful. You can redesign a terminal screen by changing the message format service definitions without changing the application logic. And conversely, you can update business logic without changing the screen layout. Sometimes you get a follow-up question that says, how does an application program specify which format to use? So you can answer that. You can use insert call against the input-output PCB with the mod name in the message segment header. And when I say mod, that means message output descriptor. This would eventually tell IMS Transaction Manager which device output format to use when rendering the response to the terminal. Now the next question is, what is Scratchpad area in IMS DC? So Scratchpad area in IMS DC is basically a storage area that IMS provides to an online application program to preserve data across multiple terminal interaction within the same logical conversation. Now without SPA or Scratchpad area, every time an MPP program terminates, all its working storage is cleared. The next time the terminal user sends a message, the program starts fresh with no memory of the previous interaction. Now with SPA, the program can save state data that include partial input, session context, user identity, current menu state. And the SPA is stored by IMS in message queues, and it is passed back to the program on the next GU call to the IO PCB. Now transactions that use SPA are called conversational transactions, and they are distinguished from non-conversational transaction by the presence of SPA in the PSP definition. Now the next question is, what is DCCTL or DC control? So DCCTL is also pronounced as DC control. It is basically the data communication control environment, and it enables you to run IMS Transaction Manager independently of IMS database. So let's say when your transaction processing workload does not actually require IMS hierarchical database. For example, the application is using DB2 for ZOS or VSAM files. So in that case, you can use DC control without the full IMS database component. And this would eventually reduce resource consumption and improve throughput. So DC control still provides the IMS transaction manager capabilities, for example, message queue, MPP regions, MFS formatting, terminal management, and recovery. Now let's move on to our part 4 of this particular video, where we'll talk about scenario-based question. Now the very first question is, let's say your program issue a GU call and you receive a GE status. Now what are the different steps you're going to follow to find out the root cause of this particular problem or this particular status that you've got? So as you all know that GE means that segment not found. So very first thing is that you need to focus on SSA, that is segment search argument. So first thing that you have to check is the field name correct? That means exactly 8 character. Second important thing is the relational operator coded correctly? Or the comparison value is in the right format? Or maybe the length of the value that you have specified is not correct. The most common cause of unexpected GE on a GU call is basically a mismatch between the search value format and the store key format. It could be a leading spaces, a packed decimal field being searched as a character, or a wrong key length. So you need to focus on that particular area first. Now the second check would be that you need to find out whether your program has issued a prior call that reposition the database cursor unexpectedly, because GU always does an absolute fetch. That means it goes back to the root of the hierarchy. That means if your SSA is on a child segment without fully qualifying the parent path, then IMS cannot find the record that you're looking for. And the third one is that is the data actually there in your database? And to verify that, you can very well use the available tools, for example, FileIt or File Manager, to verify whether the segment that you are actually looking for is available in the database or not. Now let's move on to our next question, that is your MPP program is running, but the user get no response at the terminal. So how you're going to investigate the actual problem? So what are your steps for that? Now the very first thing is, this is basically a classic IMS DC production support scenario, right? So very first thing that you need to check in this case is whether your program actually issue an insert call against the input output PCB to send a response. So this is basically a most common cause of this problem, that your program exit without inserting an output message. Now the second check would be that you need to verify the mod name in the output message header. If it is blank or incorrect, then IMS Transaction Manager may not know how to route the output back to the terminal. Now the third is you need to check the message queue. Is the output message sitting in the queue or undelivered? This could indicate a terminal issue. That means your terminal is actually in an error state, or maybe there is some problem with the terminal. Now, if all these 3 steps cannot solve your problem, then the last step is you need to review the IMS logs and the MPP region output. You can look for U0777 or any other abnormal termination code that could cause the program to exit without completing the insert call. Now let's move on to our next question, that is you need to update a field in an IMS segment. So walk me through the exact call sequence. So this question is to test whether you truly understand the hold mechanism. So the very first step is that you will issue a GHU call, that is get hold unique, with a qualified SSA. That means to identify the exact segment you want to update. So when you issue this call, IMS will retrieve the segment into your input output area and place a hold on it. Now the second step is in your program working storage variable, you need to modify the input output area. That means you need to change the value of the field that you want to update. And remember, you cannot modify the key field, you cannot change the segment length, and the input output area must contain the full segment, not just the replaced or change field. Now the third step is you will issue a replace call. So this replace call will be issued against the same PCB using the same input output area. And do not specify a qualified SSA on a replace call, otherwise it will fail. Eventually, IMS use the hold from the get hold unique call to locate the segment and replace it with the modified input output area content. And if you attempt a replace without a preceding get hold unique call, you will receive a DJ status code and your update will not be executed. Now the next question is you need to insert a new child segment under an existing parent. How do you code it? So when you insert a child segment in IMS, you need to use an insert call. So first of all, you need to provide SSA, that is segment search argument, that navigate down to the hierarchy until IMS finds the parent segment. And after that, you have to include an SSA for the child segment you want to create. So before issuing the insert call, you need to make sure that you load your input output area with the data for the new child segment, because IMS take the data directly from the area during the insert. So in nutshell, how it works is that IMS first locate the parent. Once the parent is found, it will insert the child segment in the correct position based on the database definition. For example, your key sequence, in case if key sequence is not there, then something else would be there. That depends how exactly your parent and your childs are actually organized in your database. And in case if IMS cannot find the parent segment, the insert will fail and it will return a GE status code. And this is why production program normally perform a GU call first to confirm if parent exists or not. And then they attempt to insert a child segment. So this is how actually it works. Now the next question is, what is a secondary index in IMS and when would you use one? So as you all know that a secondary index gave IMS another way to find data beside the primary key. I hope you have heard about the concept of primary key and secondary key, right? So normally IMS access root segment using their defined sequence field, for example, retrieving a customer using a customer number. But sometimes there are requirements where application need to search using a different field. Maybe you want to find customer by date of birth, account type, or an email address instead of customer ID. So this is where a secondary index actually come into picture. So it actually create an alternate access path so program can retrieve segment using another field without changing the primary database structure. Technically speaking, IMS actually store this index in a separate index database that maps the alternate key back to the actual database record. Program then access the database through a secondary index PCB and use the alternate value in the SSAs, that is segment search argument. But secondary index are not free. They actually come with a cost. So every insert, update or delete may also require IMS to update the index. So the rule is simple. Use secondary index whenever the application genuinely need that, because secondary index add overhead and can reduce performance in high volume systems. Now the next question is, what is the difference between a full function database and a fast path database? So full function database, for example, HSAM, HISAM, HDAM and HIDAM actually support all DLI calls. For example, get unique, get next parent, get hold unique, etc. etc. And they're the standard IMS database type stored in VSAM or OSAM datasets. And they actually support sequential and direct processing. Now, fastpath database are designed for extremely high volume, high throughput transaction processing. And There are two types of what you call fast part database. First one is data entry database, and second one is main storage database. Now, data entry database store data in areas rather than standard hierarchical segment and is optimized for rapid insert, rapid retrieve of high frequency transactions. For example, ATM transaction or real-time security trade. So again, data entry database support a subset of DLI calls, and it has own recovery and buffer management mechanism. Now the last one is main storage database, and it was a memory resident database for extremely fast access. But IBM has replaced it with data entry database using the virtual storage option or VSO. In this case, the frequently accessed areas are kept in memory. Eventually, it will provide performance which is equivalent to MSDB, and it will also support the robustness of disk backup recovery. Now, let's talk about our next question, that is, what is database recovery control? So, database recovery control is the IMS component that manage logging and recovery of IMS databases. It tracks all changes made to the database through online log dataset and maintain records in the recovery control dataset. It actually controls which programs are authorized to access which database, prevent unauthorized concurrent access, and provide the metadata needed for image copy and recovery operations. So when a database needs to be recovered after a failure, then in that case DBRC supply the recovery manager with the logs that needs to roll forward from the last image copy to the point of failure. And remember, at production support level, you will interact with DBRC through the DBRC command interface. So from there, you can issue commands to mark the database available or unavailable, checking the recovery status and authorizing recovery jobs. Now let's move on to our last segment, which is basically a rapid fire section. So in this case, we'll look at a couple of important terms that you should be aware of when you are just appearing for interview. So very first term is segment. It is basically a basic unit of data in IMS. A segment is a named collection of fields stored together as a unit. It is something similar to a row in a relational table. The next one is root segment. It is basically the topmost segment in the hierarchical structure. It is the only entry point in the database record. And every dependent segment is ultimately a child of the root segment. The next one is twin segment. So it is basically a multiple occurrence of the same segment type under a single parent segment occurrence. So let's say if a customer has 5 accounts, then there would be 5 twin segments at the account type under the customer root segment. Now the next one is PCB mask. So it is basically a data structure in the COBOL program linkage section that map to the program communication block. So after each DLI call, IMS populate the field in PCB mask, including the status code, the key feedback area, and the segment level number. The next one is go back versus stop run. So IMS program must terminate with go back, not the stop run. And it is very common thing that you need to remember, right? So go back actually return the control to IMS, allowing it to perform necessary cleanup, commit, and roll back the unit of work and release the database hold. In case if you use stop run, it will eventually terminate the entire address space, bypass IMS cleanup, and potentially leaving the database in an inconsistent state. Now the next one is CBL TDLI, and the full form is COBOL to DLI, that is Data Language Interface. And in plain term, CBTDLI is the name of the IMS interface module that a COBOL program calls to communicate with an IMS database. When your COBOL program needs to issue a DLI call, for example GU, GN, or insert, it does so by calling CBL TDLI and pass the required parameters such as the function code, PCB mask, input output area, and segment search argument or SSAs. It is basically a bridge between your COBOL application code and the IMS database engine. The next one is DFS RRC00, and it actually stands for Data Facility Storage Region Resource Controller 00. It is basically a suffix indicating the base or the primary version of the module. So in plain term, it is the IMS Region Control Program. So it is basically an entry point that the JCL invoke to start and manage an IMS dependent region, such as a batch message processing, that is BMP region, or a message processing program, MPP region. So it actually set up the runtime environment that allow your application program to connect to IMS and issue TLI calls. Think of it as a launcher that gets the IMS execution environment ready before your COBOL or PLI programs run. The next one is logical child and logical parent. So IMS support logical relationship between physically separated database. So a logical child segment in one database can point to a logical parent segment in another. Eventually it enable limited cross-database navigation without a full relational join. Now the last one is a difference between GE and GB status code. So GE means a specific segment was not found, and GB status code means that it's an end of the database. So we have reached the end of the video, and as you have seen that you have already covered the full spectrum of IMS interview question, right from the foundational architecture of DBD, PSB and PCB through every DLI call in the arsenal. We've also covered IMSDB transaction regions, MFS, SPA, DCCTL, and we have also looked at a couple of scenario-based questions. So eventually, this is a complete set of questions that would eventually help you out in your IMS interviews. So if you like this video, then please consider subscribing to our channel because we need your support. Apart from that, do visit our YouTube channel because we publish content on mainframe and architecture regularly, and I'm sure it will help you in enhancing your knowledge. So once again, thank you so much for watching the video.